I'm Dr. Jim Deutsch. I think it's important to take apart what the GE spokesperson was quoted as in the news, which is that it's a natural entity, and that what the problem is not uranium, but the general public's, so to speak, fear of the unknown. So there's a problem with that. One is that it's true that uranium is a naturally occurring element, but in fact we evolved as biological creatures above ground with virtually all of the uranium below the ground, safely away from our DNA.
Yes.
Now we're bringing all of this stuff above ground in different forms, and it goes into the body, and uranium is an emitter that will release particles with energy that can damage the DNA and various tissues and organs in the body close up. When the GE people talk about that living next to the reactor is about equivalent to one flight from Toronto to Vancouver, they're talking about gamma radiation, which is the high energy radiation that can penetrate tissues and pass right through. What's happening with uranium and the reactors, which produce 200 isotopes that never existed before humankind created them, what those various isotopes do is they go to specific organs in the body, reside there, emitting lower energy particles that then will damage the molecules within the cells, within the tissues of those organs. Children are especially susceptible, especially newborns and pregnant mothers. If you look at what happened with Chernobyl, and if you look past the hype and propaganda of the industry people and the governments that work with them, and that's published in this extensive report based on hundreds of papers.
And sadly, one of the doctors or scientists died while doing this. I mean, a lot of the people trying to do statistically significant work are dying in the process because they were contaminated.
Right, they get close
So
up.
what was this point about low dose as opposed to high dose? Because that was a
low
That's
energy.
very important. Yeah, could you
Low
say that
energy.
again? It's so counterintuitive
Yeah.
to think that
I think that's
low
real.
doses are even more dangerous to human health than high doses of gamma rays. Could you help me understand it?
It's not the dose. The dose would be the number of particles per
Okay.
second disintegrating. This would have to do with the energy of those particles that are released from these isotopes. And the lower energy particles actually travel less far, and it's counterintuitive, you're right, but they produce more damage locally precisely because they are lower energy. Lower energy doesn't mean they're harmless, it just means that they travel less far before they're absorbed by the molecules that are within the tissue. So they don't get out of the body, they stay right there locally. So if you have something like uranium, which actually binds very closely to this double helix that we all know about in the DNA, then it's releasing these so-called low energy particles, and they're producing the damage right there in the DNA, right there in the nucleus. And I think that's the conceptual part that people have to realize, is that whenever an industry spokesperson says that, well, this amount of radioactive material produces an amount of radiation equivalent to a flight to Vancouver, they're just talking about the gamma radiation, which is the higher radiation. There's also alpha and beta radiation, which are lower energy, and they get into the body, and that's where they cause the damage.
So is it okay that they're putting uranium up their stack, fugitive emissions out the windows and doors, and down the sewer?
It's definitely not okay, because the uranium actually gets into the DNA itself within the tissues.
But
Through the water and through the
Yeah.
air. Is that it?
And the eating of the
Local
plants
gardens? How about
that are
local
grown,
gardens?
local gardens.
Could some of the emissions from, say, the GE plant that lands down in DuPont, are those some low energy emissions that could get into the plant change?
Yeah, any kind of molecule
Gardens.
could precipitate out directly from the air or in a rainstorm. and contaminate local gardens.
But there's some experts who would differ from your opinion, and they would say that it's completely okay. And we've actually been hearing from lots of these experts, many who work for Lockheed Martin, but or there was a physics professor quoted in Inside Toronto saying, I have no idea, no reason to think it would be unsafe.
Well, what I would say is that a growing number of people are getting wise to these kinds of statements. I don't know the particular physics professor, but if we look at the tobacco lobby and the history of how the tobacco companies in various ways influence scientists who speak out for them, and in fact that some of these very same scientists, those who are still living, are actually working in the climate denial camp. They can sound very scientific, but they aren't. I think it's important for people to know the difference between science and scientism. Science is actually directly knowing something through experimental procedures. Scientism is something that looks scientific. It's possible to produce nice-looking graphs and tables and to do fancy things with statistics, with numbers, and come up with the wrong results that are divorced from reality. Science is about knowing reality. It's very important as citizens for everyone to really ask these questions. And particularly, is this science or is it scientism?
You worked in some radioactive areas in the past, or with radioactivity?
I did my PhD in biochemistry and postdoctoral fellowship in California, where we worked with radioactive isotopes as part of measuring and determining biological and biochemical processes. So I was trained in working with radioactive materials, and we were monitored every month in terms of the radiation badges. What I only really came to realize later is that this radiation badge that was on my lab coat was only measuring one type of radiation, which was what I was saying earlier, the higher energy gamma radiation. It wasn't measuring that lower energy radiation that was going into my body. For example, I was working with radioactive iodine isotopes to label proteins, to follow them, track them through the metabolic cycles within the cells. I-125, iodine-125, and other radioisotopes of iodine go into the thyroid, and there they create local damage, especially in children, again, and in fetuses and pregnant mothers.
And so what are you doing now with that PhD?
Well, I moved into medicine now, and I actually moved up a level to the brain. I'm a psychiatrist practicing mainly clinically with children and families, but at the same time I'm using that the knowledge that I've gained to try to understand how did we get to this point where we have committed ourselves to countless generations that will have to maintain these radioactive waste pools or depots from generation to generation to generation, forevermore, essentially. We're talking 1 million years for some of the isotopes.
What do you think of this whole idea that raising this information has been fear-mongering?
This is an accusation that's made?
Yeah.
Well, I think we need to be afraid. We need to be damn afraid. We need to be terrified. And we need to use that not to paralyze us, but to act.
And what do you think of some of the rhetoric coming out, like some of GE's statements?
Well, for example, GE's the spokesperson at the Lansdowne and DuPont plant that's quoted in the newspaper used a couple of phrases. One was to say that uranium is natural, and it's a naturally occurring element that was meant to stay in the ground. And the other one was that she talked about the fear of the unknown being the problem. And I'm afraid of what is known. And it's very well known, and it's very accessible now that we have this internet. The information's there, and people hopefully will come to know it and be afraid, very afraid, and act.
But so if this has been doing this and this is how you feel about it, do you think it's reasonable to ask them to shut down in the meantime while we do?
Yes.
What's reasonable?
Yes, there should be a moratorium. There should be a shutdown until all the facts are brought to light and it's assessed around what we do know around the health and medical consequences.
So, and like, how do you think we're going to get that done?
Well, that involves, it's a big question, and it's a local question, and it's a global question. I think that the fear, if there is fear, is the fear of speaking out, and that's especially true among the scientific community. There's a fear of counteracting the mainstream narrative, and I think, you know, we all experience in the G20 what's coming, which is a highly militarized police force that has shown it's been, you know, at Jane and Finch and places like that, sorry to single any of them out, but it's been going on for years, that if you rise up or stand up, you'll suffer, and you'll suffer greatly, and your family can suffer greatly. And I think it's coming to a neighborhood near you.
But that's what people are afraid of, and that's why they're saying just be polite, just let Andrew Cash deal with it. But that's why there was a mobile command unit waiting for us at GE. Yeah. Does that surprise you?
It doesn't at all. No, I think there's billions of dollars at stake in this industry and the related industries. What we have, I think, if we get a stranglehold on nuclear, we've got a stranglehold on. It's like, you know, at the conference here today, talking about Line 9. You know, if you can stop the pipelines, if you can stop the mining of uranium, let alone the processing, then you're getting a stranglehold on rapacious and murderous industry.
So, and what's the connection to the United Church? You wrote.
Well, the United Church of Canada we've had a moratorium on developing any part of the nuclear fuel cycle.